Now we are ready for prediction. Okay, so let's test this model. Let's create a text entry here and write here testing model. Okay, and push it up. First of all, let's create a variable image. Image is equal to, we have to pass that this image path we have to pass. Okay, so first of all we have to perform some pre-processing. So use TensorFlow, and in TensorFlow go to Keras, and in Keras go to pre-processing, and in pre-processing go to image, and in image go to load img. Okay, and in load img we have to pass this image path, this image path. Okay, just pass here this image path, and second one is our target size. Okay, this is our size of image which we are going to pass to the model. To set a target size, let's go here and see what target size we have used for that image at the time of training. So at the time of training we have used this 64 cross 64 format. So use the same format. If you use different format then you will get error. Okay, so use the same format. So use here 64 cross 64. So we have successfully passed the path of that image, that test image path. We have successfully passed in this load img function, and this is our target size, which is 64 cross 64. Okay, now we have to convert this image in array form, because our model will only accept numerical values. So we have to transform this image in numerical form. So define here one variable input array, and in input array use tensorflow.keras, and in this go to pre-processing, and in pre-processing go to image, same, and in image go to img to array function, img to array. Okay, and in img to array pass this image which you get from this path. This thing will convert this image into an input array. Next step is to convert this input array into numpy array. Okay, so convert this input array, use np dot array and pass in list format input array. Why we are doing this? Because we are interested in converting this single image into batch. Okay, we need a two-dimensional array. Okay, that's why I am using this square bracket to convert this in two-dimensional array. Okay, so right here converting single image to batch, because our model is trained on two-dimensional array, so we need to convert this input array into two-dimensional array. Then only our model will do a prediction. So we have successfully converted this single image into batch. Next step is to perform a prediction. Okay, so first of all what we have done, we have taken that image by using this load img class and pass the path and the target size. Target size is same as the size used for training. That same size we have to use here, and then we have converted this image into an array. After converting it into an array, we have converted that input array into numpy, two-dimensional array. So this step is converting single image into batch. Okay, now we are ready for prediction. So let's perform prediction. So use prediction is equal to, we are going to use that CNN model which we have loaded here. So use CNN dot predict, and pass here input array, this one, this two-dimensional array, and this CNN dot predict function will predict the result of this input array, and that result will be stored in this prediction variable. Okay, now let's run this entry. So we got our prediction. So let's do prediction. So if we print this result, we have here prediction. Okay, we have used here predictions, so use right here predictions. So this is our prediction. Why I have written here predictions? Because This is a confidence score of each classes. This model is predicting that one probability is something 1.000, this one, that it's belong to first class. From here it is clear that model is predicting that it belongs to first class, which is very high. Now we have to identify what is the name of these classes. Okay, so to get the class name, we need this test set to be loaded. So we have to load this test set. Okay, so let's go here and copy this complete code from here. Okay, just copy this code and just paste here. So this is our, here we have to change this to test set, and here the directory we have to choose here, this one, just choose this directory. So we have to paste here. So let's paste here this test set directory, and everything else will be same. Okay, so run this. If you run this, then you will get 359 files belonging to 36 classes. So we are interested in finding the class name. So use here test set dot class names. If you run this, then you will get the class name. So first class is of apple. If you see here, this one is the first class, which is of apple. Second class is of banana. This second class is of banana. Third class is of beetroot. So what we are going to do here, we are going to extract the maximum value from this prediction matrix and take the index of that maximum value, and we will directly go here in this list, go to that index, and we will return that this is the prediction of our model. Okay, so here maximum value is this one, so it belongs to 0th index. So if we get this 0th index and we access this list 0th index, then we get apple. Okay, and our job is done. Now our task is extract this maximum value index. Comment out this, right here result index. We are interested in prediction result index value. Okay, and use here function np.where, as we are dealing with numpy array. So use here np.where and pass here prediction 0th. Prediction 0 means predictions is a 2D array. So we are interested in this 0th element. So this is a prediction 0th element. So go in prediction 0th element and say when its max equal to predictions 0th. Okay, so this function will return this prediction 0 is, if we do a prediction 0 here, let's do a prediction 0 here. So prediction 0 will return this list which contain confidence score of each classes, and we are interested in maximum value of that prediction 0 when it is equal to that prediction 0. So record that index. Okay, so using this we are going to, it's a numpy function, it will do a element wise comparison and check this maximum value in which element of prediction 0 this max of prediction 0 is equal. Okay, it will max of prediction 0 will return this one. If we perform here, if you are not understanding, then I am going to show you how it's going to work. Okay, so let's write here predictions 0. If we do this, then you will see here max of prediction 0 is returning this 1.0. Okay, so this max of prediction 0 is going to do a element wise comparison with all these 36 classes of elements. Okay, so it's going to compare this 1.0 with all these 36 elements of this list, and when you got equal, when this max of prediction 0 is equal to this prediction 0, then np.where function will return the index of that element. Okay, so it will check this 36 classes. So here it will be equal. So when we will print this result, if you are going to print this result index, then it will return this array 0. Okay, so this we need, so it's returning array 0. It will also return a numpy array which is having element 0. If we do like this, then we will get 0th index. So it's returning that it's a 0th index. Okay, so we are interested in this thing. Now we have to again display the image. Let's display that image again. Display image. So to display image, use plt.imshow and pass that img, this img you have to pass. Okay, img contain this image path. So just use this statement here again. Okay, just copy this code from here. Just copy this code from here. Okay, and paste here. Paste here. Okay, if you run this, then you will get this test image again. So we got this test image, and now we have to perform a single prediction. Okay, so to perform a single prediction, just write a print statement and we have to use this format function. And in this, what we have to do, so we got this index. Okay, if we do one more time, then we will get exact element of that index. So we are getting this 0, and if we run this, then we are getting this list. So we got this index. We will just pass this index value in this one, and we get our result. Okay, just pass here test class names, and in this you have to pass result index, and result index you have to pass 0 and again 0. Okay, because it's also a 2D array. If you print this, then you will get a numpy 2-dimensional array. To access the element of this array, we have to pass here 2 times 0 0. Okay, if we print this one, dot class name you have to use your test set dot class name. Okay, now if you print this, you will get it's an apple. Okay, so what we have done so far, so this model is predicting the confidence score of each classes. Okay, and we are interested in extracting the maximum confidence score. So we got the confidence score of each classes from here, and this test set dot class name will contain the each classes. So by doing element wise comparison with this maximum prediction value, we got the index of that maximum prediction value, and we are just going to pass this index in this list to get the result of our model. Okay, so here we are getting the result that it's an apple. Okay, suppose I am going to use this beetroot. Okay, this is the image of beetroot. So it's a beetroot. I am going to copy the path from here, and just you have to modify it here. Just modify it here. Okay, just modify it here. Do Control V and just run this. If you run this, you will get this beetroot, and then run this cell again, run this one again. Don't run this one because we need it one time only. Just push here. Okay, and we have run this one, we also run this one. Now let's run this again. If you run this, then you will get that it's a beetroot. Okay, if I am going to use again another one, like I am going to use this image, copy path, just change here and do Control V, run this. So it's a cabbage. Run this cell again, run this prediction result. It's showing it's a cabbage, and if I perform prediction, then it's showing it's a cabbage. Okay, we can check on another one. Let's use this bell pepper copy the path from here and paste here in this image path. Just go and paste here, do Control V, run this. It's showing it's if you do single prediction, then you will get that it's a bell pepper. Okay, so our model is giving a good result. Okay, so what we have done, so first of all we have imported this library and we have connected with Google Drive to access the data set. We have done this test image pre-processing, test set pre-processing. So this is same as I have explained in this training image pre-processing. Just you have to pass this one because we already train on this parameter, so we are going to test our model also on this parameter. Okay, so just pass here, just copy this code from this training fruit vegetable.ipynb and just pass here directly and just change the path with this test one. Okay, here we are using train and validation subdirectory, and here we are going to use this test directory. Okay, as in our data set we have this 3 directory, train, test, validation. So here we are going to use test directory. So TensorFlow is detecting that this test directory consists of 359 files, each having 36 classes. Okay, next step we have done, we have loaded our model by using that train model.h5 file which we have saved here, here we have saved this. So after executing this line, you will get this train model.h5 file. Just download this file, and after downloading this file, just upload from here and copy the path here and just performing tensorflow.keras.model.load model, load the model in this CNN variable. Then we have done this visualization of that single image using CV2. So we pass this path, we define a path of that image, then we use cv2.imread to read the image, and then we use matplotlib to form a visualization of that image. And then we have done this prediction by loading this image using the same size which we have used at the time of training, converting that image into array, and then converting that array into batch by performing this np.array. Then we have executed this cnn.predict function. Before these things we have done because our model will only accept the values in this format. That's why we have to perform these type of pre-processing before passing it for prediction. Okay, then we got our result and we explore more in this prediction. This prediction is returning a confidence score of each classes. So we are interested in extracting the maximum value from this prediction list. So we have used this np.where function to extract the maximum value index. Okay, so we have used these things to compare which one is the maximum in this prediction 0 list, and np.where function will return the index of that element. Okay, so we got our index, and we just pass in this set.class name list to get that model is predicting to which class. Okay, so that's why we have used this test class name, and we just pass this result index, this one we have just passed this value in that class name index. Okay, and that model is giving that bell pepper. So these things we have to perform in this project. So congratulations to everyone, we have successfully built this model which is able to classify 36 classes of fruits and vegetable. Initially we have imported our data set from Google Drive, how we can perform training image pre-processing, validation image pre-processing, how to build a model, how to compile a model, how to record the history of the model, and how to save the model and how to save the history in JSON format. We also calculated the accuracy of model. We have done visualization of training accuracy with respect to number of epochs and validation accuracy with respect to number of epochs. And then in this testing model.ipynb file, we have tested our model. First of all, we have done this test image pre-processing. Then we have loaded our saved model. Here we have saved this model. So this trained model, pre-trained model we have loaded here. And then we have done image visualization on which we have to perform our prediction. Then we done a lot of pre-processing to pre-process that image. Then we perform the prediction, and at last we are getting that it's a bell paper, so we are getting correct result. So that's all for this video. It's a final video on this project. We have successfully completed our project. Thank you guys, thanks a lot for watching this video.